Hey guys, welcome to another episode on my channel. So today I'm going to teach you how to use this 2N7000 MOSFET. This is N-channel MOSFET in order to control some LED light strip wire. And I have like 20 centimeters of this wire connected to my breadboard pins. So I'm just going to plug it in. All right. And of course we are going to need my ESP32 microcontroller, and we are going to need a bunch of jumping wires. And just to mention, this ESP32 microcontroller works on 5 volts, so I'm going to use my computer power supply in order to run it. And our LED light strip wire works on 12 volts. For that we are going to need this 12 volts power supply. So first thing that you should be careful about, it's actual choice of your transistors. These transistors that I am using for this example can dissipate up to 0.4 watts, and that is actually not too much. For example, this LED lights strip wire can dissipate 7.5 watts per meter. That means that single color it's dissipating 2.5 watts per meter, which means that we can use these transistors to control safely up to 16 centimeters of LED light strip wire. Just for this episode purpose, I'm going to take a risk with 20 centimeters of LED light strip wire. So with NPN transistors we are going to connect source to the ground, drain to the color pin, and gate we are going to connect with these 10K resistors. Of course, from these resistors I am going to make connection with pins on my ESP32 microcontroller. And there is actually only one more important thing that I have to mention, and that is common ground. In order for this system to work, we have to connect ground from ESP32 microcontroller to my 12 volts power supply. But be very careful not to mix wires. If you accidentally connect anode from a 12 volts power supply to ESP32 microcontroller, well, from that moment on you can start considering buying another microcontroller, because this one is probably going to be burned because it cannot tolerate more than 5 volts. And I have to mention danger to your computer. You could easily damage USB port on your computer and even more. So for that reason, be very careful. So on one side of my breadboard, I'm going to connect 12 volts on plus and ground on minus. Now I'm going to connect these two grounds because we are going to use common ground. All right. So on this side I'm going to have 12 volts. On this side I'm going to have 5 volts. And first I'm going to connect this 12 volts to common anode on my LED strip wire. Now I'm going to connect these transistors. All right. First I'm going to connect sources of my transistors. So first pin is the source to the ground. Same with all of these three. Now drains from transistors to color pins. So first it's green. And we already have some lights, don't worry about that. We are going to solve all of that later on. Now I'm connecting red. And third transistor is for blue. All right. Then resistors to gates of our transistor. Now it's a bit messy. And one more. Okay, so now our microcontroller. On microcontroller side, I'm going to connect common ground first, and I'm actually going to use this wire. Common ground, it's in here. Alright, I'm going to use pin 17 for blue. Let's see, where is the blue? Okay, it's in here. Then I'm going to use pin 21 for red, and I'm going to use pin 22 for last color, and that is a blue. Okay, so now I'm going to plug in my microcontroller to my computer, and now we are going to deal with the code. So first we are going to create references towards our pins. So red, it's general public input output pin num_22. Green, it's num21, and we have one more. Blue, it's '17. All right. Now I'm going to initialize my serial monitor with now a baud rate of 9600. Now set pin mode for these 3 pins. So we have red output. I'm going to copy this. Red, green, and blue. All right. In void loop, we are going to make delay of 100 milliseconds first. Then what we are going to do? We are going to use analog write, and analog write takes 2 arguments. First argument is actual pin, and we are going to have 3 more variables: int r for red, int g for green, and int b for blue. Set all to 0, and that is going to be second argument, r for red. So what is the point with this? Analog write function as second argument is going to take an integer from 0 up to 225. Long story short, with this number you are going to scale output voltage for that pin. That means that bigger the number is, the bigger voltage you are going to have as output. And in this way we are actually controlling strength of our color. And I'm going to copy these 2 more times. So we are going to do the same for green with G and blue with B. All right, and now we are going to change our colors. So first thing what I'm going to do, I'm going to check if red, for example, it's less than 225. We are going to add 1 to blue, or better 10. We want to change our colors much faster. Now, if blue is bigger or equals to 225, we are going to add 10 to green, and we are going to reset blue. And I'm going to copy this for red color. All right. Now, if green it's greater or equals to 225, I'm going to add 10 to red, and I'm going to set back G to 0. And here it's not green, it's G, and it's not blue, it's B. Because in here we are dealing with integers, not with pins. Okay, I'm going to save this. I'm going to build this code, and I'm going to upload it to my microcontroller. Okay, I am going to open my serial monitor in order to see what we are going to get. Ah, yes. First we have to print something. I want to print values. So red column %d tab, then green column %d tab, and blue column %d new line, and now R, G, and B. All right, now I'm going to build and upload this code once again. I'm going to open my serial monitor. Okay, we are getting values. Now you can see color change on LED lights. And you can compare that with values that we are getting from our serial monitor. Now I'm going to fast forward this in order to see actual real change. Alright guys, that's all on my part. From this moment on you know how this thing operates and you can create your own color patterns. So that's all for this episode. I hope that you learned something new, something interesting. So please like, subscribe, and see ya!